Let's begin by exploring the fundamental building block of all matter, the atom. Everything around us, from the air we breathe to the devices we use, is made up of atoms. An atom is the smallest particle of an element that still retains the chemical properties of that element. Atoms themselves are made up of even smaller particles called subatomic particles: protons, neutrons, and electrons. Protons and neutrons are packed tightly together in the nucleus at the center of the atom, while the electrons move around the nucleus in regions called energy levels or shells. Each type of atom is unique, defined by the number of protons it contains. This number is called the atomic number, and it's what makes hydrogen different from oxygen or any other element. Understanding the structure of the atom is the first step in grasping the fascinating world of chemistry. Now let's dive deeper into what makes each atom unique: the atomic number and the mass number. The atomic number is simply the number of protons found in the nucleus of an atom. For example, every hydrogen atom has one proton, so its atomic number is 1. The mass number, on the other hand, is the total number of protons and neutrons in the nucleus. Neutrons add mass but no charge, while protons add both mass and a positive charge. By looking at both the atomic number and the mass number, we can identify and distinguish between different elements and even different forms of the same element, called isotopes. These numbers are often written alongside the element symbol, with the mass number as a superscript and the atomic number as a subscript. This notation helps scientists quickly understand the composition of an atom at a glance. Next, let's look at how electrons are arranged in an atom. Electrons occupy specific regions around the nucleus called energy levels or shells. The first energy level, closest to the nucleus, can hold up to 2 electrons, the second can hold up to 8, and the third also holds up to 8 electrons. As each shell fills up, additional electrons move to the next available shell. This arrangement is called the electron configuration, and it's crucial because it determines how an atom interacts with others, whether it's stable or likely to react. For example, atoms with full outer shells like neon or argon are very stable, while those with incomplete shells like sodium or oxygen tend to react to achieve stability. Understanding electron arrangement helps explain why elements behave the way they do in chemical reactions. Finally, let's see how elements are classified into metals and nonmetals based on their electron arrangement. Generally, metals have 1, 2, or 3 electrons in their outermost energy level, making them likely to lose electrons and form positive ions. Examples include sodium, magnesium, and aluminum. Nonmetals, on the other hand, have 4 or more electrons in their outer shell and tend to gain or share electrons during reactions. Elements like oxygen, nitrogen, and chlorine are nonmetals. There are also a few elements like boron and silicon that don't fit neatly into either category. This classification helps us predict the properties and uses of different elements, from the metals that build our structures to the nonmetals essential for life.